All right. Well, welcome to the ITS Michigan Lunch and Learn with Integral Blue on C-V2X. This is a topic that's been a hot button discussion for several years, but there are still questions out and around about what exactly V2X even is, all the way to what are these new technology changes that are happening, and what can infrastructure owners and integrators and consultants and vendors, et cetera, do um, about those changes, and how do they affect what our plans are for V2X in the ITS space. So you are aware, teams may have notified you already, but we are planning to record this session. It is recording now. And a link to download a recording, if you wish to have it, will be made available sometime after the webinar, hopefully soon. We also have a Q&A pod open in the chat where you are welcome to post your questions. It is separate from the regular Teams chat, so if you have any questions that you would like us to address in the webinar, please post them in the Q&A, and we will absolutely address those. Planning to have about 10-15 minutes at the end of the webinar for open discussion, which is where we will likely address those questions. But going ahead and getting started now, V2X and C-V2X specifically, how is it different from DSRC? What funding opportunities are available if one wanted to deploy one of these technologies? How do these FCC changes that have come out in recent years affected things, and where do things seem to be going now? My hope is to address several of those questions and probably more through the course of this webinar. To start out, I want to talk about the whole concept of V2X communications itself. What really establishes the need for V2X is the fact that sensors can only tell you so much. Even the most advanced Tesla vehicle that exists on the market right now, or autonomous vehicles that come out in the near future focused on sensors equipped on the vehicle itself, all of those sensors still rely on line of sight. If the sensor can't see beyond the vehicle in front of it or the vehicle next to it, let alone miles up the road, it's impossible for the vehicle or its driver to know what's happening through those obstructions. And that's where communication becomes extremely powerful. You can see on this example slide from the US DOT just a handful of applications made possible through V2X communication. And you may notice that all three of them in this case, forward collision warning, lane change warning, emergency electronic brake light warning, all really shine in situations where the driver can't see what's happening next to or in front of them. So this technology was developed to solve this problem and focuses on sending and receiving messages, not by creating access point connections like your phone does to the Wi-Fi in the office or to a cell tower, or by creating client-server relationships. The term V2X really encompasses a whole family of standards and technologies for exchanging information in a consistent format between any entities that share the road together, which could include roadside infrastructure, vulnerable road users like pedestrians or cyclists, etc., and of course, vehicles themselves. However, because there are so many different types of devices communicating together, terms that were originally used when this technology was being developed, like vehicle to vehicle, vehicle to infrastructure, vehicle to pedestrian, etc., became too restricted, really, and kind of confusing when trying to understand what all of these vehicle to whatever acronyms are talking about. So V2X became the umbrella term incorporating all of these interactions between entities that are sharing the road, and even entities that may exist beyond. However, there's still some confusion, I think, around what constitutes V2X and how to incorporate other communication mediums that may exist in the same kind of ecosystem. This graphic developed by Qualcomm is a really good illustration of how direct communication and network-based communication are really starting to coexist under what we're calling V2X. You have cellular networks that can be used to deliver or collect information from vehicles that have an integrated cellular modem inside of them, or even personal mobile phones or aftermarket modules that might get installed in a car. However, I'm going to be using the term V2X throughout this presentation to specifically refer to direct entity-to-entity communications, not going through a cellular network or any other kind of external network unless indicated otherwise. So now that we've had this brief overview, let's talk about DSRC versus C-V2X. This discussion can get political in the broader sphere. That's not my goal here. Our goal is not to make endorsements about a specific protocol or a specific technology, but really to help explain the technical differences between them and how anybody in the audience today may navigate this world of changing technology. To start, though, hopefully you'll bear with me, and hopefully this isn't too weedy in the engineering details, but I do want to start with an extremely high-level overview of networking. So network technologies, whether it's a computer that's connected to your dock at your office desk or your phone that's connected to the Wi-Fi or to a cellular network, all network technologies exist in layers that form a stack. You do not have to read, let alone memorize, all of the things in this graphic, but there are a couple of things I want to highlight. The top of a networking stack is where the rules for how applications like software can take their data and package it into packets that can be sent over a network are defined. The bottom of the stack, the physical layer, contains the rules for how the binary ones and zeros that make up data that's being sent can get translated to a physical medium, like voltage that changes on an Ethernet wire, or light on a fiber optic strand, or in the case of V2X and many other technologies, radio waves for wireless communications. The layers in between address how packets are moved through the network and are largely not the focus of our discussion today. V2X is no exception to this networking stack. It has its own implementation of a networking stack, and the key to understanding the difference between DSRC and C-V2X lies in knowing that there's a difference between the physical transceiver standards for how the radio interface functions and the network or application level standards for the messages that they contain. Starting with DSRC, DSRC stands for Dedicated Short Range Communications and was the first V2X technology to get developed. It's also known as WAVE, or Wireless Access in Vehicular Environments, but most people know it as DSRC. This is the technology that most of the standards were developed around. The physical layer, where the rules are defined for how wireless radio waves are exchanged with DSRC, is actually a specialized branch of the Wi-Fi standard. If you're familiar with 802.11ac or AX or any of the other Wi-Fi families, DSRC is actually 802.11p. It also introduced a family of networking standards called WSMP, or the Wave Short Message Protocol. This is really the networking layer of how DSRC works. And finally, at the application layer, it introduced J2735. This is an SAE standard that defines what these wave short messages should contain and how they should be structured. Conversely, C-V2X has two functions. It has direct communications, just like DSRC, from vehicle to vehicle or vehicle to anything else that's nearby, and network communications, shown on the right, just like traditional cellular, using the same exact technology that your phone uses to connect to a tower. This direct function is also called PC5 sidelink. That's the standards name for it, just like DSRC. This is message focused, just like DSRC, and is used for low latency, short range, high speed, ad hoc communications. It does not require access to a tower or cellular service at all. It also doesn't require a SIM card or any kind of cellular subscription. However, as you can imagine, the network function of C-V2X, also referred to as UU, although don't ask me what that stands for, is network focused. It's been referred to in times past as vehicle to network. This uses typical cellular LTE or 5G connectivity and is really good For applications that have higher latency tolerance, it doesn't need to be millisecond or sub-millisecond communication, and it supports higher bandwidth applications, such as downloading high-resolution maps or downloading firmware updates for a device in the vehicle. However, this does require access to a tower, cellular services, and a cellular subscription. Coming back to our networking stack illustration, at the physical layer of C-V2X is based on LTE, or the original version of it was anyway, the most common version. This standard is under the jurisdiction of 3GPP, or the Third Generation Partnership Project. This is the consortium standards body that governs and develops all of the cellular networking standards, from 2G originally, all the way up to 5G, 5G new radio, and everything else that's currently in development right now. The V2X functions are part of that family of standards. They're not its own standard like DSRC. And really, the key to this is that it uses different broadcast technology. The way that data is turned into radio waves and sent or received over the air is the key difference here between C-V2X and DSRC. The networking, application, and security aspects of the V2X communication is all the same as DSRC. It still uses wave short message protocols. It still uses J2735 structured messages, and it's really meant to be a drop-in stack replacement for DSRC, but while retaining all of the messaging and networking and security developments that have been made over the last 20 plus years. This is really key to understand, I think, because there's been confusion in the past, especially when C-V2X first became popular, around whether this was just a complete wipe of the board. Are we starting over from scratch? How is this different from DSRC? Why is this change even happening? And really, it's a different physical layer technology. It's really different in the way that how your phone connects to Wi-Fi and communicates to an access point versus the way your phone connects to a cellular tower and communicates that way. Different radio waves doing different things, but carrying the same information. To summarize the differences between the two, especially when it comes to performance, C-V2X purportedly has increased range over DSRC. A quote from a study that was done on this showed the results showed that vehicle-to-vehicle communication range for basic safety messages, which is the primary message vehicles produce, can be as high as 1,100 meters, and the V2I communication, or vehicle-to-infrastructure, in a clear line of sight scenario can be at least 1,400 meters. The textbook per standard range for DSRC is 1,000 meters. This is proven and through countless demonstrations. In fact, it's worth noting that DSRC in some cases had range beyond 1,000 meters tested, in certain scenarios. It's also worth noting that these purported range improvements haven't been proven to the same level as DSRC simply because C-V2X hasn't been around for as long. Similarly, C-V2X purportedly has increased performance in areas of throughput, performance at high vehicle speeds, tolerance of congestion, etc., due to differences in the physical radio. A good illustration of where this becomes relevant is when vehicles are moving at high speed, the radio waves that their devices are producing for V2X are vulnerable to the Doppler effect, just like sound waves are. And C-V2X handles that effect differently than DSRC, and those differences in some test scenarios can result in farther range at high speed, providing longer reaction time for the driver. C-V2X is also intended for both direct and network-based functionality, like we saw in a previous slide. Conversely, DSRC has only ever been direct only. C-V2X also has the advantage of being included in the ever-evolving progressive cellular standards, whereas DSRC has its own, I guess you could call it dead-end, branch of the Wi-Fi family. Whether to call it a dead end is fair or not, I guess remains to be seen. But it is worth noting that because V2X direct communication functionality is just one aspect of the larger LTE and 5G standards, that function gets carried into progressive versions of cellular technology. When 6G eventually comes out, it will likely include V2X functionality. DSRC branched the Wi-Fi standards. It's its own thing, 802.11.p. So as new Wi-Fi standards come out, those new standards don't carry DSRC's functionality with them. It would really require a rebuild of DSRC to take advantage of Wi-Fi broadcast and reception improvements that have been made in Wi-Fi 7, for example. So that's another key differentiator. And however, with these purported improvements, it's worth noting that C-V2X is new. It has not undergone the same level of testing as DSRC because it hasn't been around as long, and it even still has some components that are in development. A good example of this is handling a special type of message called the wave service advertisement. To put it succinctly, a wave service advertisement, or a WSA, is an announcement that tells vehicles what kind of services an RSU can offer. For example, a common use of this is telling vehicles that priority and preemption requests are available at an intersection. So if an approaching emergency vehicle gets that announcement, that advertisement, it could respond by sending the intersection a request for priority treatment. If that WSA isn't present, then the vehicle has no way of knowing it could even make that request. And this has caused problems in deployments in recent years trying to get this to work. WSAs have components in how they work that are rooted in 802.11, the Wi-Fi aspect of DSRC. So porting or translating those functions to C-V2X has proven difficult at a technical level. Despite these contrasts and comparisons, when it comes to deployment, C-V2X has had heavy adoption in China. It also looks to be the direction that we're going here in the States due to FCC changes. But DSRC, or its European equivalent, known as ITS G5, as is known overseas, has had heavy adoption in Europe and in Japan. So where things will shake out, I guess, remains to be seen, but global automakers will have to contend with a potential dual market with this technology. So moving from just pure comparative differences between DSRC and C-V2X, I want to talk about the spectrum itself. So the FCC has made changes. I think everybody knows that by now, but what are those changes and what exactly do they mean? Starting at the beginning, V2X and its functions, for it to be truly safe, required dedicated, reserved, protected spectrum. It can't operate in a spectrum that's going to have heavy interference from unlicensed devices because it would inhibit the signal's ability to be sent or received. In response to this, in collaboration with ITS America back in 1999, the FCC reserved 75 megahertz, which equates to about 7 channels, for ITS and referred to it as the safety spectrum. The rules that the FCC developed around this safety spectrum directly reference DSRC. And it was split, like I alluded to, into 7 channels. Some of these channels had special uses, but the point really is that we had so much bandwidth available originally for all of the applications that we could dream of using V2X for. The only channel of note, I guess, that I'll highlight here is the safety channel. Messages that you may have heard of, like MAP and SPAD and BSMs, or basic safety messages, were all sent over channel 172. It's the bottom of the frequency, closest to Wi-Fi, and that's what most messages operated on. But we had all of this space for doing really just about anything that you can imagine within the spectrum we had available. However, there was a problem. A mandate to include DSRC in new vehicles was never adopted. We got really close. One was drafted. It was even submitted by NHTSA for review, but it was never signed. It was actually rescinded a few months ago, I think in November. And because of this, automakers never consistently implemented it. Despite hundreds of DSRC infrastructure deployments around the country and the full backing of the US DOT, it never took off in the vehicles. In response to this, the FCC reassessed the 5.9 gigahertz spectrum in 2019 and determined that the 75 megahertz that had been reserved for DSRC was not being adequately used. As a result, they issued an NPRM, or a Notice of Proposed Rulemaking, basically an announcement that says, hey, we're going to change how things work. They issued it late in 2019 in December to shrink the spectrum and to formally induce a new competing technology called C-V2X. After this NPRM was issued, they did open it up for comment, but largely ignored comment from industry and infrastructure owner operators. As a result, they did pass their NPRM in 2020, which effectively means they started developing new rules. But we'll come back to the rules and where that timeline sits in a minute. So where the spectrum is now. 45 megahertz at the bottom of the spectrum has been reserved and opened for unlicensed Wi-Fi use. If you're familiar with Wi-Fi, you may have heard of terms like 2.4 gigahertz versus 5.8 gigahertz. The left side beyond that black box there, the left side of the spectrum range is unlicensed Wi-Fi, 5.8 gigahertz. And they've opened up another 45 for that unlicensed spectrum to grow upwards. They left 30 megahertz for anything V2X or ITS related. Yeah, and this proposal, like I mentioned, was passed by a vote in 2020, but the rules have not yet been formalized. So here's the current state of affairs. For about 3 years, that blue bracket you see in the middle there, V2X deployments essentially halted. New RSUs, or roadside units, because I haven't used that acronym in the presentation yet, need to be registered with the FCC. All registrations are subject to an approval process, even if the agency already has a license to operate in the spectrum. With this new Notice of Proposed Rulemaking, the FCC stopped approving new DSRC installations. Moreover, all DSRC installations had to vacate the lower 45 megahertz of the spectrum and move to channel 180, which is the bottom of the 30 megahertz that remains, by July 5th of 2022, which is the orange box that you see on the timeline. However, since new rules haven't been developed yet, the old rules specifying DSRC are still in effect, meaning deployments of C-V2X, despite the fact that the FCC has endorsed it, are non-compliant with their own rules, and as a result, they require a waiver or a temporary experimental license. The FCC took until 2023, actually during the week of ITSA last year, to grant its first C-V2X waiver. This is a joint waiver applied collaboratively among multiple infrastructure owner operators, RSU and OBU manufacturers, and other interested parties. But that did pass, and it kind of opened the floodgates because they passed another joint waiver in August, pretty much immediately after the first one. Whether or not there have been more after that, I'm uncertain, but there have at least been 2 large joint waivers approved for those parties to use C-V2X in the 5.9 gigahertz spectrum. Until the new rules are formalized, deployers need waivers. And even when the new rules do come out, they'll likely need to apply for new licenses that address those new rules. As you can imagine, these changes have had a significant impact on the technology itself. Like I've kind of mentioned earlier, DSRC is permitted now to continue to operate until told otherwise in a 10 megahertz channel 180 in the spectrum that remains. That's all that's available. And really, it's a stopgap to allow infrastructure owners the chance to migrate their infrastructure to C-V2X if they want to continue using this technology. And my expectation is that when the new rules are published and waivers are no longer necessary, that the new rules will include a formal sunsetting date for DSRC. At the moment, though, previously registered and licensed installations are permitted to continue to operate as long as it's in this channel. Moreover, there's a single 20 megahertz channel available for C-V2X. Because it sits between 180 and 184, it's been designated channel 183. Different from how DSRC functioned, it is a 20 megahertz channel, so it has, even though it's one channel, it has double the bandwidth of what we would consider a single channel previously. But as you can see in the diagram, it overlaps with channel 180 that's being used by DSRC. This makes co-location of dual installations basically impossible. And in fact, if you're going to sign up for a waiver, they require you to work with any DSRC incumbent owners and coordinate with them so that you don't cause interference for their existing installations. As you can imagine, with only one channel, it's kind of difficult to operate as many applications as were originally planned for DSRC. There's concerns about congestion. There's concern about unwanted interference from Wi-Fi. And in response to this, industry is working to prioritize applications and determine how many can coexist without a detrimental impact to their performance. And I'll talk a little bit more about that in a minute. Turning from the technical differences to practical application, how should you prepare for C-V2X deployment if this is something that you're interested in and maybe aren't familiar with? There are three areas of readiness I want to talk about. The first one is in regards to our friends in the FCC that we just finished discussing. Like was mentioned, if you're going to deploy C-V2X, at least currently, you need a waiver or an experimental license. A waiver is essentially blanket permission. An experimental license is smaller in scope, shorter in timeline, but generally easier to get. So if you have a C-V2X project that you're thinking about and you want to deploy but don't have any waiver or licenses yet, recommendation is to apply for both a waiver, maybe by jumping onto a joint waiver that might be in draft right now, and an experimental license at the same time. You'll likely get the experimental license approval first, and hopefully that gives you enough time to get your project going while you wait for the waiver. And the next consideration for FCC readiness is the fact that you need to register your new RSUs. This actually isn't a change. DSRC installations needed to be registered with the FCC already because you're operating in a licensed spectrum, and new installations likewise need to do that too. FCC certification. So this is a new consideration. Since C-V2X is considered experimental by the FCC, equipment manufacturers who maybe were using DSRC previously need to get their new C-V2X devices certified for operation by the FCC. There is at least one manufacturer who has theirs right now. There may be more. And how exactly this affects the ability to get approvals, I'm not 100% certain about, but looking for RSUs that have their FCC certification is recommended to help prevent approval issues with the FCC. And I guess a final tip regarding FCC readiness, mentioned this already, but if you can get on a joint waiver that others may be applying for at the same time, that's definitely recommended. You can even take all of the same language from the previous ones and just recycle it, which is what the second joint waiver did. That makes it really easy for the FCC to look, okay, this is exactly the same as what was previously approved, stamp it, send it through, and will prevent issues. It also helps ensure that whatever way you're planning to deploy C-V2X is consistent with the way other agencies and parties are doing so. Applications. It's not in this list. I probably should have added it, but before I get to the four things that are there, having a strategic plan with what you want to do with V2X is strongly recommended. Before you really want to think about where to put RSUs, what to integrate them with, or even what applications to use, thinking about what your goals are for V2X, what needs and problems do you want it to solve, is the first place you should start. Once you've established that and you've synchronized that with maybe you have an ITS master plan, that can really help you get several feet forward in trying to plan a deployment. Once you have that, or maybe in the process of developing that strategic plan, application considerations should be made. Because the way the technology is evolving right now, when DSRC was first being deployed and being popular, cellular internet was not as reliable as it is currently. As a result, we really planned to do anything and everything over DSRC. Now we have a shrunken spectrum, lower space or smaller space to run applications in, and we have these cellular technologies. Most production vehicles now have a cellular modem built inside of them. You can deliver information to an infotainment system. So what applications do you want to use in one medium versus the other? So trying to figure that out is definitely something you should do. Generally speaking, if an application requires short range, is sensitive to latency, meaning you need millisecond or sub-millisecond timeliness of delivering information, using C-V2X is recommended. This really, really shines at intersections. If you have vulnerable road user detection that you're trying to deliver, or even just signal phase and timing, that's really good to do over V2X. There are some things you can do over cellular at an intersection, but they're difficult and require, I guess, predictive speculation on how a signal timing is going to change. But anyway, examples of maybe network-oriented applications you could use. I mean, we talked several years ago about running road weather alerts, like road condition alerts over V2X. You get somebody who detects, like a road weather information system detects black ice or the likelihood of black ice on a bridge, generate a connected vehicle message so that vehicles approaching the bridge are notified appropriately. You can do that pretty easily over a cellular internet connection instead. You don't need to do that over RSUs or over V2X. You can deliver the information miles in advance. So latency really isn't a concern. And there are lots of examples like this. A tip, I guess, something that's kind of in vogue right now are what I call surrogate, or what some other people call pseudo vehicle-to-vehicle applications or messages. Prime example of this are vulnerable road users or unconnected vehicles. So you have an intersection and you use LiDAR or video analytics to detect objects in the intersection and their position and their movement information, like vehicles that aren't connected or vulnerable road users, pedestrians, cyclists, etc. And then you can have RSUs broadcast messages on those objects' behalf so that vehicles that are connected can see them as if they had connectivity of their own. So that's really popular and is happening on a few grant projects that I know of, and is worth looking at to try to bridge the gap of connectivity that still exists. And finally, kind of related to that, is infrastructure readiness. Depending on what applications you choose, communications requirements may change. Delivering high amounts of data to a back office system, like taking all of the messages from vehicles and piping them into a server somewhere, that can be data intensive. Using fiber is probably recommended, at least a local network, not a cellular modem network. Also, the ability to remotely access and reboot devices for easy maintainability it can be extremely valuable. It can lower your O&M costs for RSUs and generally makes maintenance staff's lives easier. Edge processing is another recent consideration. This is directly relevant to the kind of surrogate apps I was just talking about. If you're going to do something like video analytics at an intersection to generate connected vehicle messages for objects, having a processor there in the cabinet that can handle all of that data is pretty much necessary. They have lots of other uses too. It's really popular right now, especially in research and grant deployments that are happening, to try to abstract the intelligence, the logic that we've tried to shove into controllers and RSUs in recent years, pull that logic and intelligence back out and put it in a standardized, dedicated piece of hardware running standardized software that can harmonize all of those data inputs and really help achieve consistent behavior and consistent experience for drivers without needing to worry about whether the RSU you're deploying can handle applications like signal priority requests, or whether your controller can encode SPAT messages by itself and deliver those to the RSU. So edge processing and the power and space and network requirements for it are good things to consider when assessing your infrastructure readiness. If you want tips on these things, two very useful documents that I'm going to touch on in a couple of slides in more detail. are two that have been put out by the Connected Transportation Interoperability Committee, or the CTIC. They are 4001, which is an RSU standard, the new RSU standard, and 4501, which is a guidance document. But I'll touch on those in a minute. And the big ticket question that's probably forefront of most people's minds is, if you're even interested in deploying V2X, how do you pay for it? Thankfully, between the past and through all of these FCC and technology changes that have happened, one of the new changes that's very beneficial to everybody is a tremendous source of funding that did not exist before. Blessed be the Bipartisan Infrastructure Law, or the BIL. The US DOT has made many grant programs available through it. I'm certain that most, if not all of you, have heard of many of those programs. Something new that the US DOT posted recently is essentially a fancy search engine. So if you're looking for a grant program to fund a specific type of deployment, you can go to transportation.gov/grants/dashboards, as you see down there at the bottom, and really search for grant programs across any number of eligible activities or eligible applicants. It's extremely convenient for seeing what's available for funding right now, at least through the US DOT proper. A couple other useful resources. US DOT has an entire list of all of the grant programs that are being funded by the Bipartisan Infrastructure Law. It's not just 3. There are more that my screenshot didn't capture here, but they have a list of all of them at the link you see at the bottom, how much funding they provide over their 5-year life, with the program name, etc. And then in turn, you can take that information and look those up at this page that has a table of notice of funding opportunity links for those grant programs, and then vital information about when they're being posted and when they are expected to close for new applications. So 3 very useful resources for trying to find federal funding for honestly lots of different kinds of ITS deployments, not just V2X, but V2X is a common use case for many of them. Some highlights, if you're interested. The FMCSA has their own special programs. One of them is the High Priority Innovative Technology Deployment Program, and it is focused specifically on commercial motor vehicles, as you can expect. But really, it's really open-ended. MDOT has been doing work zone deployments through this program. It is really a fantastic source that I'm not sure many people are really looking at. Something to note, whatever program you want or project you want to do through this program does require alignment with the state program plan top level design, or the PPTLD. The PPTLD usually defines a set of goals around commercial motor vehicles, problems that you want to solve. For example, work zone navigation for commercial motor vehicles. So the technology you're deploying needs to be in service of one of the things in that list. Another really popular grant program right now is the Safe Streets for All, or the SSFA. This is focused on multimodal roads and street applications. It's really covers a range of initiatives to prevent death and serious injury on surface streets. So think congested urban areas, especially, that have lots of different modes of transportation happening all at the same time and in close proximity to each other. The ATTAIN program, which is formerly the ATC MTD program, is focused on advanced technologies around safety, mobility, efficiency, system performance, connectivity between different modes of transportation, and especially infrastructure return on investment. A specific called out use case that they reference in their notice of funding opportunity is DSRC to C-V2X retrofits. So if you have existing DSRC infrastructure and you want to replace it with C-V2X, the ATTAIN program is an excellent source of funding for that. The SMART program is probably the most well-known in this short list. This is a special program that is providing grants for demonstration projects. It's 2-phase. You have phase 1 applicants up to $2 million. You basically pitch a concept, and then if you win, you prove it. So executing a demonstration pilot for a unique technology or a unique use of an existing technology. And if that's successful, you're eligible to apply for phase two, which is up to 15 million and is really intended for you to take that concept that you prove in phase one and scale it up. So definitely worth looking at for many different types of ideas. If you have something that's been rolling around in your head that you want to try, but are uncertain of how to fund it, SMART is definitely worth considering. And then, of course, there's our venerable CMAQ funding sources. I expect most, if not all of you, are already familiar with that, but really its open-ended nature makes lots of things possible through CMAQ, from replacing signalized intersections with roundabouts all the way through V2X deployments. I know a lot of V2X deployments of Michigan have been made using CMAQ funding. So if you're already familiar with this program and aren't doing anything with V2X, but you want to start, it's a great place to start doing that. One more side note. The double asterisk items, which are the SSFA and the ATTAIN grants, and there are others not in this list, do require a 20% total project cost match. So that your total project cost, US DOT will only fund 80% of that. So if you can work that into their total available funding to try to calculate, what your options are, but that is worth keeping in mind, of course, if you want to pursue one of those programs. So finally, where do I start? I'm interested in deploying this technology. How should I go about doing that? What resources are available to figure out what my first step should be? To begin, the two documents I mentioned a few slides ago, the CTI 4001 and the 4501. 4001 is the new RSU standard. If you've been in this space for a while, you may be familiar with USDOT's 4.1 standard that made its way as a reference into many RSU special provisions that I've seen over the years. This replaces that. And it goes in depth. If you're trying to develop an RSU special provision and don't have one already, consulting this standard is definitely recommended. You can also just reference it in your SP, and people should know what you're talking about. 4501 is a little more in depth. This is not a standard, it is a guidance document. There's a problem that even with the existence of standards, having consistent implementation from coast to coast across the country is hard. There are lots of ways to deploy this technology and lots of different applications and use cases. And even within the same application, you can have different agencies implemented in different ways or using different combinations of technology. So this guidance document, new version is expected to come out this year, but this is intended to guide agencies on how to deploy this technology consistently. And it uses red light violation warning as a use case. It requires calculation of a vehicle's position and speed to determine whether it has a chance or a high likelihood of running a red light if it doesn't adjust its speed. So very important for safety applications and pretty complex to make work consistently. So they use that as a use case. But if you build infrastructure that can use red light violation warning consistent with this guidance document, you can run just about any other V2X application you can think of. Finally, there are two plan documents I recommend looking at. ITS America has their national V2X deployment plan that they released in ITSA last year. And then the US DOT has their Saving Lives with Connectivity plan to accelerate V2X deployment that was, at least a draft of it, was published late last year. Both of these documents are intended to provide a roadmap for national deployment. They focus on different things, but the US DOT's is very interesting because they lay out near, medium, and long-term plans related to everything from how many intersections and how much freeway coverage do we want to have in the next 10 years to recommendations for how many security credential management systems should be available and interoperable with each other, how many OEMs should have V2X in new production vehicles, and similar recommendations. So if you want to start developing, for example, your own V2X strategic plan, both of these documents would be good to look at if you want to make sure that what you're planning is in alignment with what is happening, or at least is expected to happen at a national level. So That is it, actually. I thank you very much for your time, and we are right on schedule with 14 minutes available for Q&A. I have not been looking very closely at the chat, but it doesn't look like we have anything in the chat currently for Q&A. So I guess if there are any questions, please feel free to drop them in the chat or raise your hand and we can unmute you and you can address them verbally if you like. All right. Well, if there aren't any questions, then again, thank you for your time. And I guess, Mr. McIntosh, do you have any closing remarks that you would like to make?
Not overall, but Ted, I want to say that was I've got a couple text messages from people attending. That was a very well put together and very informative webinar. Best one a lot of people have said they've been on in a while. And it is 100% has to do with that bow tie. That's the only reason, really. But no, I appreciate, Ted, that information, passing along to everybody here. This again was a very full a webinar, and I hope everybody took something out of it. Can you do me a favor though, and Ted, and send the attendee list via Teams afterwards? I think you guys are the host or organizer. So after the meeting, you can go into it, and I'll have like an Excel spreadsheet you can email afterwards, just so we have that for our records as ITS Michigan.
Yes, of course.
Perfect. Alrighty, that's all I got. Thank you again, Ted. Any last remarks from your end?
No, I don't think so. So again, thank you for your time and attention. Hopefully you got your lunch in while you were listening. I'm going to go have mine now. So yeah, and like I said at the beginning, a link to the session recording will be made available in days hence, along with the presentation slides if you're interested in those. So thanks again, and have a great rest of your day.
Bye, everybody.